Hello everyone, good morning. This is Mr.DHAKSHUNHAAMOORTHY, Assistant Professor, Artificial Intelligence and Machine Learning Department. I am handling subject 22 CS 302, Computer Organization and Architecture, Unit 2, Arithmetic Operations, topic Booth Multiplication. Booth multiplication. The Booth algorithm is a multiplication algorithm that allows us to multiply two signed binary integers in 2's complement representation. It is also used to speed up the performance of the multiplication process. It is very efficient algorithm. It operates on the fact that the strings of zeros in the multiplier requires no additional bit, only shift the rightmost string bits. In the case of string of ones in the multiplier, from bit weight 2 power k to weight 2 power m, that can be considered as 2k plus 1, 2 raised to the power of k plus 1 minus 2 power m. For example, plus 14 binary represented value by using binary weightages 0 0 triple 1 0. Here binary weights 2 power 1 to 2 power 3 places we are getting 1, then k is equal to 3, m is equal to 1. Then 2 power 4 minus 2 power 1, that means 2 power k plus 1 minus 2 power m, right? Then we are getting 16 minus 2, the value is 14. Like m into 14 is represented m into 2 power 4 minus m into 2 power 1. This same as all multiplication schemes, Booth algorithm requires examination of the multiplier bits and the shifting of partial product. The second rule is period to the shifting. The multiplicand may be added to the partial product, subtractand from the partial product, or left unchanged according to the following rules. The multiplicand is subtracted from the partial product upon encountering the first least significant 1 in a string of ones in the multiplier. The multiplicand is added to the partial product upon encountering the first 0, provided that there was a previous 1 in a string of zeros in the multiplier. The partial product does not change when the multiplier bit is identical to the previous multiplier bit. By this slide, we can able to understand the operation of the Booth algorithm. Here, the sign bits are not separated from the rest of the registers. The registers we are using is A, B, and Q are renamed to accumulator BR and QR respectively. Extra flip-flops QN plus 1 is appended to the QR. It is needed to store almost last right shifted bit to the multiplier. The pair Qn and Qn plus 1 inspect double bits of the multiplier. Here we are using BR register, complementer and parallel adder, then AC register and QR registers, sequence counter. For the Booth multiplication, we are using, these are all the different hardware modules. Booth algorithm, here the flowchart they given, which helps us to understand this concept very easily. The multiplication of 2's complement data, Booth multiplication algorithm. This algorithm can be used for both the positive and negative multiplier in 2's complement form. The partial product does not change when the multiplier bit is identical to the previous multiplier bit. Qn and Qn plus 1 equal to 0, 0 or 1, 1. The multiplicand is added to the partial product if LSB is 0 in the string of zeros in the multiplier Qn and Qn plus 1 equal to 0, 1. The multiplicand is subtracted from the partial product if the LSB is 1 in the string of ones in the multiplier Qn plus 1 equal to 1, 0. After each addition or subtraction, the partial product is shifted right using the arithmetic shift. In this flowchart, once the number is entered, multiplier and multiplicand BR and QR, AC equal to 0 and Qn plus 1 is 0, sequence counter is initialized to n. After initializing the values of quotient and accumulator and sequence counter, then we are taking the Qn and Qn plus 1 values. If it is both are equal 1, 1 and 0, 0, we are not doing any changes. But when we are having the Qn and Qn plus 1 values 1, 0, then we are performing AC gives AC plus BR dash plus 1. Else, if it is our Qn and Qn plus 1 is 0, 1, then we are adding AC gives AC plus BR. After that, the resultant of this is shifted right and sequence counter is decremented by 1. If the sequence counter is not equal to 0, then we are repeating this process till the sequence counter is getting 0. Once it is completed, we are ending the process and we are getting the multiplication results. From this example, compute minus 5 into minus 7 using the Booth algorithm. Here there are 5 different columns we are creating for and doing this Booth multiplication. One is operation description, another one is accumulator value, another one is QR and Qn plus 1 and sequence counter. Sequence counter, here number of bits we are using is 4-bit values. That is why we are initializing sequence counter to 4. Then we are starting our process. Here we are checking Qn and Qn plus 1 is 1, 0. When we are having this value, we have to add accumulator plus BR dash plus 1. Then we are getting value 0, 1, 0, 1 and 1, 0, 0, 1 and zeros. See, after performing this operation, we are doing the right shift so that we are getting changes. Now sequence counter is getting decremented. Now we are checking whether it is 0 or not. Here 3, then we are continuing repeating the process for the next cycle. Here Qn and Qn plus 1 is 0, 1. Then we are performing right side operation, that means AC plus BR. Here, after performing AC plus BR, we are getting 1, 1, 0, 1, 1, 1, 0, 0, 1, and we are performing right shift, and we are getting the result Qn and Qn plus 1 is 0, 0. Because of that, we are not doing any operation. Simply, we are moving to the next cycle. That is why sequence counter alone getting decremented.